And good afternoon. Thanks to the organization for accepting this presentation. My name is Vicente Queral for the National Fusion Laboratory, Sept, in Spain. And I'm going to present liquid divertor targets and walls for the liquid Stellarator reactor. The project has been funded by two Spanish institutions and European funds. And the objective of this work is to try to find integrated solutions to cost issues in the deuterium tritium Stellarator reactors and try to validate them at small scale. First, I will talk about the problems of the cost of the blankets and the hot cells. Later, the potential solution, that is the new concept of Stellarator fission reactor. Later, the concept of floating lithium as first wall for ASTER-CP, and possible lithium-based concepts for ASTER-CP divertors. Perhaps a novel concept of distributed divertor. We know that the blankets, after they are damaged by neutrons, we have to replace them. Blankets are large, are activated, we need large remote handling equipment, and we have to prefabricate this blanket again and again during the lifetime of the reactor. The cost of this could be, well, thousands of millions of euros. Also, we need a space to put these blankets during temporary here, these hot cells, very large, and the cost also thousands of millions of euros. A potential solution is Stellarator. There are two elements, main elements in this Stellarator. The first are liquids kept by centrifuge force around the plasma, and these liquids in general will be molten salts. And the second element are neutron concentration, because the magnetic field here at the cores is higher than at the cylinder, with the objective of having no bleeding material or only thin material at the cores. The first element would be a layer of about 55 centimeters of thickness to produce the tritium, to extract the power, and very important in this case, to protect the cylinder from neutron radiation. We'll aim at low recycling regime because the advantages that all we know. So we need a thin layer of liquid lithium at less than 450 degrees centigrade on the molten salt, if possible. We'll see. For that, we need low melting point molten salt here, like this type of fiber, and as a backup, lithium chloride, lead chloride. Here we see the properties of this reactor with certain parameters. The second element, neutron concentration. Most of the ions bonds here at this area, so most of the reactions are here, and the power and the tritium production. So perhaps we need, we check that, little breathing material here. We found reasonable magnetic configuration, you can see here, that fit inside the cylinders. And these are all the parameters of the reactor. Here we produce an experiment of water swirling inside this cylinder. We observe permanent regime here, the uniformity of the fluid, and no droplets of spray coming from the liquid to the plasma that will be here at the center. Relatively small waves at the free surface, and this is the experimental device. Simulations performed by one company for us that replicates the experiment, and the results are similar. Another option is to have a rotating cylinder instead of swirling. The advantages of the concept is simplicity, low constructive and operative cost of the plant, because we want to avoid blankets, so we avoid the cost of the hot cells, the remote handling equipment. And this is a lot. In total, perhaps 10,000 or 20,000 million of euros per cost per reactor. Also, Stellarators are relatively simple to operate and have many other advantages. No time to talk about that. long lifetime because lipids are not damaged by neutrons and there are no thermal cracks. And likely, it depends, likely high power produced because lipids can store low power. This is important for current social trends. As difficulties or drawbacks, well, the potential existence of these minuscule drops of spray that may come from the liquid to the plasma. We did not observe at a small scale, but we'll see. The chemical compatibility of lithium floating on the molten salt and wettability. We have ongoing tests. MSD drag, we perform some tests also, and corrosion issues of the molten salt. We patented the concept. At the moment, we are looking for some company to expand this patent that is only protected in Spain to other countries, could be China, United States, and these are two pages. This is a public document. The concept of lithium floating as concept for the first world. The function should be to be an electric conducting material facing the plasma, that is important, and particle pumping. We know all the importance of that. But this liquid wall will be thin, 10, 15 microns to MSD, if we don't reduce the magnetic field normal to the surface here. We can see in some places the magnetic normal field is relatively high. Also, perhaps if we increase the viscosity, we can do something. All the potential issues, perhaps formation of rivulets of lithium and runaway lithium flow collapse. These are two experiments of galinstan inside a small cylinder of 20 millimeters length. We see here at the left that at 17 revolutions per second, the centrifuge galinstan is kept, the flow. Some small instabilities are observed, but it's kept. The thickness is 0.6, 0.7 millimeters. At 13 revolutions per second, the centrifuge galinstan collapses and a big drop is created. Note that the magnetic field here is from 0.1 to 0.4 teslas, depending on the position. We cross-checked these experiments with our analytical expressions of MSD, and we advanced a bit on the concept. We also perform experiments in the same cylinder of galinstan inside the cylinder in this Halbach array of 1 Tesla at the center. And at the beginning of the video here we see the drop as in the previous experiment, but at the end we see that the drop disappears and we have a surface of about 0.2 millimeters thickness. The thing is that it's so viscous that centrifuge is not necessary at the end. You have a pastry there. It seems that it's an optical effect. It is rotating at 60 revolutions per second, but it's a synchronism in frames and revolutions. We have also some ongoing experiments. It's only one experiment. This is the experimental setup with RTA, thermocouples, video camera, and several things. Here we observe the mixture of lithium chloride and lead chloride. We increase the temperature at the beginning to create the eutectic, and heat the gases, and later we solidify it again. Later, lithium bits are dropped. Here, the bit of lithium were dropped on the solidified eutectic, and the temperature was gradually increased. This is very recent, 15 days, and the only result that we can say is that strong gassing spills were produced. Here you can see the result of the spills after the creating of the eutectic. That chlorine gas appeared here after 330 degrees centigrade. And lithium was not wetting and not well molten on the molten salt. Here is solid, the molten salt, here is liquid. The lithium drops, lithium bits, the surface is reacting with something. And here also the molten salt, and at the end disappear. The molten salt disappeared because reacted or vaporized. We'll see the results and we produce more experiments. The lithium-based concepts for the divertors, and perhaps this novel concept of distributed divertor. We are trying to have a kind of surface here, you can see, colloidally and toroidally relatively large, where the ionized particles will be distributed This is the opposite to the normal thing that is done in common divertors, where they concentrate the particles in straight lines or troughs, depending on the type of the divertor. We take the advantage of pumping of lithium, otherwise we cannot pump the particles. And it is also only possible for Stellarator due to the particular magnetic configuration. Promising initial results, but still this is tentative. We will see what happens. We patented this recently, and we call the spread heat surface or Equi-power surface and distributed divertor. A CPS could be possible for these surfaces that are really sometimes convex and sometimes sharp heads. We would like high-speed moving films at some areas if possible while it's unclear. Should be on ceramics. We have the data from Dr. Science. Yes, could be. Also, divertorlets for some areas could be possible. But I prefer moving fields on molten salts in order to protect the solid surface from neutron radiation. But it is more dubious and problematic. We'll see if it's possible to have this. Another option are liquid lithium jets, as proposed, for example, in free-force helical reactor. But we know from stock that the deflection of the jets were 10 millimeters for this small device, and this is a lot, even if they were insulated. And gravity jets here in force-free helical reactor, they calculated a deviation of 40 centimeters. And also the implicit temperature of the certain jets was 2000 degrees centigrade, that is very much, if not turbulence or surface convection existing. Another option would be beams of droplets at high speed, like was proposed for ITER in this paper, at 160 meters per second. But all the concepts have some problems, both for droplets and for jets. One problem, it seems that gravity jets or droplets are not enough for reactors because the power that you can extract in principle is we calculated that. Also, it happened in force-free helical reactor, also some results from the T3M tokamak. Another issue, droplets and jet deviation. Even if droplets, some comments from Dr. Molotov and also from the experiments in stock, it seems that there will be some millimeters of deviation. What happens then? That if you have deviation of the droplets, the first line will have an acceptable power. It was, in some jet experiments, it was experimented with one lamella, that is the protuberant lamella, receive a lot of power, gigawatts. Conclusion. Stellarator reactor concept with centrifuge breathing and sealing materials on cylinders and neutron concentration have been proposed and initially validated. A patent on the concept is just now available for expansion by any interested company. Experiments with galinstan and the magnetic field were produced, and we started experiments of lithium floating on molten salt. Perhaps a novel special surface was tentatively obtained to distribute ionized particles. And this is only appropriate for low recycling regime and for stellarators. The best liquid materials divertorial method is being studied for ASTER-CP and for a new ASTER. Help and contributions for these concepts are welcome. Thank you very much. If you have questions.